Hi, I'm Xiaochuan, and now I'm gonna talk about the mega heat waves. Let's read two pieces of news first. In 2003, the Europe has went through an extremely temperature of over 40 degrees C, and over 70,000 people died. In 2010 in Russia, another heat wave came, and it is 10 degrees C higher than normal, and caused 55,000 deaths and a huge economical loss of about $15 billion. It is said the heat wave was the most lethal environmental issues, and thus I choose this paper to understand the formation of mega heat waves. Based on the yearly data of soil moisture and temperature, a co-variability of diagnosed pi is developed, which presents the correlation between two parameters. In this is the anomalies of temperature and the anomalies of contribution of soil dryness. And as we can see, into year 2003 and 2010, the pi is as huge as 12, which means the soil moisture deficit would greatly intensify the temperature. And also in this graph, we can see that in the top, there is an increased temperature from pre-heat wave to mega heat wave. And at the same time, when we look at the pictures in the middle, the surface soil moisture was largely reduced during this time. And in the bottom, the darker blue, the color, which is the right corner, the more positively correlated between the anomalies of temperature and the anomalies of soil moisture deficit, contributed to the surface sensible flux. So, this phenomena all shows that the soil moisture deficit is correlated with temperature. Well, it still could be a coincidence. Therefore, to further study the formation, two cities circled on the map in these two heat wave events were studied, and temperature and specific humidity were acquired, and then a mechanistic model was developed to analyze the data. Before we get to the results, a basic concept, the atmospheric boundary layer, ABL for short, is needed. It is the air layer about 1 to 2 kilometers above the surface, and due to the direct effect of the Earth's surface, a strong vertical mixing occurs in this layer, and it is important for air and pollutant transport. As we can see in the afternoon, the ABL layer is fully mixed, and the air close the surface Earth. The temperature with height decreases with height due to the more heated surface Earth. While at night, because the surface cools faster, a stable boundary layer, which with the temperature increase with height, was formed, which stopped the mixing behavior of air, and above the stable boundary layer, a residue layer with constant temperature is formed, which is the remaining effect of the mixing in the daytime. So here's the data acquired from two cities. Firstly, the model is good enough to describe the ABL layer condition, because the data observed in dotted line is fitted with the data predict at afternoon in solid line. And as we can see from the left graph, a thick and warm residue layer was formed, and thus the heat was stored at this layer, and this is normally occurred over dry soil. And in the afternoon the next day, comparing the data between pre-heat wave and mega heat wave, both the temperature and the dips has increased a lot. As it is fully mixed the next day, the heat in the residue layer will released and the heat is accumulated. Furtherly, the data at night during mega heat wave is used as initial condition in the model. And after changing different parameters, results shows that only under low soil moisture and high heat advection, an extreme high temperature could occur, which is a part circled by blue. And however, use the Pre-heatwave data as initial condition, the temperature could be 10 Kelvin lower at afternoon, and there's no mega heatwave. Comparing these two scenarios, we can say that the major difference is the thick residue layer, implying that it is a key factor of heat accumulation and temperature intensification in multiple days. Therefore, a roadmap of mega heatwave formation is developed. Firstly, the heat advection brings warm air and continuously dries the soil. And then the residue layer formed and thickened over time with heat accumulated, and air is heated progressively, and under these circumstances, the extreme high temperature occurs in days after. So that's all for the mega heatwave formation. Thank you very much.